Everyone. In this lecture, I just want to explain about the implementation of binary search tree. But before getting into the implementation part, let's see some theoretical part so that we can get the concept how to build the binary search tree code. Okay, fine. Now, binary search tree. Binary search tree itself is a binary tree, right? So before that, what is exactly binary tree? So you can see binary tree is a hierarchical data structure, right? Where each node has at most two children. What is the meaning of two children is, for example, this is a binary tree. Okay, two at most means it can have either zero child or it can have one child or it can have two children. So this is also a binary tree because it has zero children. This is also a binary tree because it has one child. This is also a binary tree because it has two children, but not more than two. Okay, so this is not a binary tree. Fine. So we got about what is binary tree, and it's a hierarchical structure because you can see it follows the parent-child relationship. This is a parent, this is a child of that particular parent. So when you frame like this, then it follow a hierarchical data structure apart from a linked list, okay, which has a linear data structure, which was fine. Now one more thing you have to observe is that binary search tree traditionally stores a distinct unique values. Okay, what is the meaning of it is that whenever I'm creating a binary search tree, it is going to store a distinct value. So whatever the concept I'm building it, I'm taking care that whatever the value I will insert, it will be distinct. It will not take duplicate values. With respect to that only, I'm going to build all the code. Fine. And but it doesn't mean that it can't take a duplicate value. Yes, practically it is possible, but whatever code we are going to write, it's on the basic that I'm going to take a distinct value. Okay, so this is our concept. Now coming to binary search tree, what is exactly binary search tree? So binary search tree is I told you that it's a binary tree. So all keys in the left subtree are less than the node's key, and all the tree in the right subtree are the greater than the node key. For example, let's take this example. There is 20 here. Okay, so all the node at the left subtree, suppose this is left subtree, and all the node in the right subtree, okay, should be less than 20. Okay, and all the node in the right subtree should be greater than 20. Okay, if you follow this part, okay, then it automatically become a binary search tree. But the thing is, this rule should be followed by every node. Every node you are inserting, this rule should be followed. For example, 20. If I want to insert one more node, for example, it is 10, then it will be in the left of 10 because it is smaller than 20. If I want to insert 30, then it should be right of 20, right? So it is lesser than 20, that's why it's in the left of 10. So greater than 20, that's why it's the right of 10. If I want to insert one more node, for example, it is 15, then where should I insert? First you have to check 20, right? Its left is 10, then its right is, then 15 is greater than, first you have to check, first of all you have to check, is 15 smaller than 20? Yes, then go to the left of it. Then you have to check, is 15 lesser than or greater than, it is greater than 10, then go to the right of it, right? Like this you have to keep on checking it. For example, I want to insert 25, right? Then where should I insert it? For example, 25 is greater than 20, you go to the left of it. Every time you start from the root. Okay, start your checking from the root. Okay, now 25 is greater than 20, you go to the right of it. Then 25 is lesser than 30, then you put to the left of 30. Fine. So this is how you build the binary. Okay, if you observe carefully, now that 20 is the root. Now let's see, its left subtree is this part, right? Now here every node is lesser than 20. Can you observe 10, 15? Here also, if you see, this is right subtree, this is left subtree, this is right subtree. Every node is greater than 20, right? Here also, if you observe, every node, there is only one node here and it is in the right and should be greater, yes. So this 10 is also following the property. So you have to check every node should follow the property of binary search tree. Is 30 following the property? Yes. 30 is left is 25 and it should be smaller than 30, right? So definitely smaller. So every node is following. 15. 15 is a leaf node which doesn't contain any node. So you don't have to check anything. So this is definitely a binary search tree. So this is how binary search tree is defined. Okay. Now let's see the implementation part of the code. So at the beginning, what I'm going to do is, let's see. See, your code will start from int main, right? Then at the beginning, I'm going to insert 10, 5, 15, 3, 7, 12, 18 in this sequence, right? So I had already written here the sequence 10, 5, 15. So in this sequence, I'm going to insert it. And while inserting, how you're going to implement the code, that is how I'm going to explain the binary search tree coding part. Fine. Now, if you see, there is a structure here, the structure of a tree, right? It is already defined. So when you write this structure, then there is a data here, there is a left and right point, right? So when you write this part of code, then this is the structure which is going to be framed. There is a data part, there is a left, there is a right. Okay, so what exactly happened is there would be some memory and that memory is reframed in this way. Okay, that's it. One cell allocates data, another cell allocate left pointer, and another cell will take right pointer. That's it. Fine. Now you can see here in this line, when you reach to this line, what is the meaning of this? Struct tree node root null. So at the beginning, we will consider that root is always null. That is how we assume it. At the beginning, we will consider the root is null. That means root is not pointing to anything, right? That means there is no tree at all, right? Now suppose you had call the function insert 10. Now what will happen? This is the function executed, insert 10. Then it will go to the calling function, which is the calling function, this part, right? Then this 10 will be passed here to the data, right? Then this 10 will be passed here to the particular data, and this is what? This is another function you are calling, that is create node. Okay, then from here you will jump to this particular code, that is create node, and this 10 will be passed here. Now let's see what this create node exactly does. Okay, so when you just called insert, this is what happened. Just there is one dot 10 is passed and it's passed to the create. Now create node will execute. Now how the create node will work is, at the first line it is written malloc. Okay, so there would be one memory block created at the beginning. Okay, just by calling a malloc function, memory block will be created. And what would be the size of that memory block? That is defined here. What should be the size of this memory block? That is defined here. Okay, that size should be according to the struct tree node. Whatever the size this particular structure will take, now this particular code will take, that would be the size of this entire memory block. Okay, fine. Now this malloc should be this particular memory block should be of what type? How would be the framing? So the type would be of tree node. So whenever you define the type, this is called typecasting, then it will automatically reframe this memory block into this structure. Okay, there would be one left, okay, there would be one data, then would be the right. So this structure will be framed just by writing this particular part. So this is typecasting. Then this malloc will automatically return the address. For example, when this memory block is created, there would be some address, right? For example, the memory block address is 100. Then this 100 is passed to this new pointer. This is one kind of new pointer. For example, the pointer is new node, name of the pointer. And this 100, whatever 100 na memory block, this malloc will return the address. That 100 will be gone to stored in a new node pointer. That means it will get 100. Then it will automatically store point to the memory block, right? That's it. Now if you observe here, the next line says the new data, its data itself. What was the data? This 10, right? So the data, new node data will get 10. And new node left at the beginning is null. The new node left at the beginning is null. And new node right at the beginning is null. New node right at the beginning is null. Fine. And after that you have to return new node. Okay, the return new node means this 100. What is new node here? New node contains 100. Okay, so name of the variable itself contains the address. So new node means 100. This 100 will be written. Okay, so whoever call this function, this 100 will be written there. So who had called that function? This part. Now you come back here. So you will get 100 here. Are you getting it? You will get 100 here. So again there would be one more pointer, new pointer. This new node is totally different pointer. Okay. Now what is happening there? This function will return a new node. That means new node means this 100. Okay, this 100 is returned here. Okay, now this 100 is given to one more new pointer, that is new node 2. See, I had changed this new node. Back then I had kept new node and new node here, so that you don't get confused is both the pointer. Both the pointers are different pointers. Okay, this pointer is for this function, this pointer is for this function. So that you don't get confused, that's why I changed the name to new node 2. So what happening is here, there is a 100 right now. This 100 is passed to this new pointer. So there will be one more pointer, which is new node 2, and it will get 100. Now this will point to this memory block now. So this new node and this new node is completely different. Now we got one more pointer pointing to this particular memory location. Fine. Yeah, now the next step is it will check. What is this? If tree is empty. That means how it is going to check is whether root is equal to null. Yeah, currently root is null. Can you see that? Yes, root is null, right? This part, the root is null, right? So if root is null, then what should happen? Root should point where the null is pointing. Root should point where the new node is pointing. Root should point where the new node 2 is pointing. So what is new node 2? It is 100. So 100 will be passed to root. So new node root will get 100. Then when root will get 100, root is also pointer and it got a address 100. Then root will eventually point to memory location 100. Now you can see new node 2, root, everyone is pointing to this particular memory location, right? Now after this, that means one particular insert 10 is done. Okay, so we had inserted the value 10, and after that you can easily happily return. So return from here. Fine. Now again, next time you're going to call what? New insert 5. So you're going to call insert 5. Now what will happen? Now again this 5 should be inserted in this tree, in this particular tree, right? Now how it is going to happen? So you are going to call a insert, then it will go to a calling function. Which one is the calling function? Insert. Okay, it will come here, right? Then what was the data here? 5, right? And this 5 is given here. Then you can directly see that it is going to create a node here. New node, one node is going to be created. How it is going to be created? Using this function. I'm not going to explain this function again. You can see it will directly create this kind of structure, okay, with value 5 now. So what is going to happen is it will create one node already like this, okay, with structure 5 inside it, and maybe its address is 200. Okay, then that address will be written, this 200 will be written to a new node. Okay, so the 200 will be written to some pointer, that is new node 2. Okay, so this will get 200. That's it. Fine. Now after that it will check again. So this new node is gone. This is no more exist because you again called the insert file. Now again it will check is root is equal to the null. Yes, root is equal to null. Is root is equal to null? No, this condition is not satisfied. Root is pointing to something, that is pointing to 100 now, right? 100th location. Then it will check again. Then this condition is not satisfied. Then it will come to this particular line. Then current should point where the root is pointing. Then wherever the root is pointing, there I will point one more node, that is current. And that means root is 100, right? So this is passed to current pointer. Then current will also get 100. Fine. Then it will point to this 100th location. Now why I had taken this one more pointer is just to traverse. Now I will get into this while loop, which is an infinite while loop. Then again I will check. Okay. Now current is here, right? Now data. What is the data? This current data means whatever the data you had given. What data you had given right now? This data was 5, right? So here it is 5. Now you will check. What you are going to check is 5 is smaller than current data. What was current data? Current data is 10. Is 5 smaller than 10? Yes, current data is this. Current data is this. And data, this data is whatever data you had just while you are calling this insert function or whatever data you pass that one. So 5 smaller than 10. Yes, the condition is true. Then go to left. That means you have to go to left. That means again you have to check. You have to check. First of all, this condition is satisfied. 5 is smaller than 10. Then you have to check is current left is null. Yes, current left is null. Then you have to, what you have to do at this part, at the left part, you have to insert this particular node. That is the meaning of it. How you are going to do it? See, here current left is this part. There you are going to put new node 2. What is new node 2? 200. So here you are going to put 200. So whenever you put 200, then it will automatically point to this 200th location, right? So can you observe? See, the new node 2 is what? 200. So 200 is passed to current left. What is current left? Current left is here, right? So this 200 is given here. Then this 200 will point to this particular new node 2, right? Now at present, let me redraw how our binary search tree look like. So you can see after insertion, this is how your binary search tree will look like after inserting 5. Okay. Now next time you will again call insert 15. You will again call insert 15. Then what will happen? This line, right? Then what will happen? Again it will go to the insert function, which is this part. Then the data is 15, right? Okay. So shall I maintain one more variable data so that you can remember it, right? I will maintain one data. It is 15. I don't know whether you are remembering it. And I will maintain the current pointer also so that you can remember. So for example, current is now 100. Fine. So this particular thing I am maintaining it so that you can remember it while processing it. Now data is 15 here, right? Now again what you are going to do is you are going to create a node. So again you are going to create one more node. Fine. And with data what? 15, right? Because our data is 15, right? Now suppose the address of this node is 300. Okay. Now this 300 will be passed here, right? Then see, this is gone. This part is completely gone. Now there would be one more new pointer. This is new node 2 and it will get the address 300. So when it get an address, it will automatically point to this particular node. Okay. Now after that, again it will check, is root is null? Is root is null? No, root is not null. Right? If root is pointing to 100. Right? Then again it will check, if root is not null, then you will again point current, whether you will take this current pointer and point to the root. Again you will do. So current is pointing to the root. So current is pointing to root. That means current contains 100. Root is 100, right? So current will also get 100. Then again you will get into the while loop. Again you will check if data, what is the data here? 15. So is 15 less than current data? What is current data? Current data is 10. Is 15 less than? No. Condition is false. Then you will come to which part? This part. Else part. You will come to this else part. So if it is not less, then definitely it would be greater. Right? So again you will check at current right. So current right. So this part is, you don't have to check, because if it is not less, then definitely it will be greater. So then you will check in the right part. So it's current right. Is it null? Yes, it is null. Then new node. What is new node? It is null. Current right is null. The condition is true. Current right is null. That new node is what? 300. Then this 300 is moved to current of right. Then what is current of right? This part. Then you will put 300 here. Then when you put 300 here, then it will automatically point to this particular location. Getting it? So can you see, it is automatically holding the structure of a tree, right? Now again we are going to call another function, that is insert 7. So what we are going to do is, no, insert 3, right? So we're going to call insert 3. So at this time our data is what? 3, right? And current is, I am going to maintain this variable so that it would be easy for explanation also and you to understand. So at the beginning current is also 100 and data is 3. Okay, fine. Now insert is 3, right? So it will go to this calling function, which is insert here. And what is the data here? Okay, we got 3, right? And we are going to create one more node with data 3, right? This function is going to do that. So I'm going to do that part. I'm going to create one node. Okay, with data 3, and suppose its address is, suppose 400. Fine. Now this 400 is passed to one node pointer variable called new node. Okay, so new node 2, there we got address of this particular memory location. So this is gone. This particular pointer is gone till now. Okay. Now again we are going to check if root is null. Is root is equal to null? Let me see. See, root is 100. Root is not null. This condition is not satisfied. Then again, current should point where the root is pointing. So again you will take this current. See, every time new current is coming. Okay, so again current you have to point to the root only. So again current will point to the root. Okay, again one new pointer current will be there, and it will again point to the root. Then root is 100, current will also get 100. So like this, current will again point to the root. Then it will get into the while loop, right, which is an infinite while loop. Then it will again check what is data now. Data is 3. So is 3 smaller than current data? So what is 3? 3 smaller than what is current data? Current data is 10. Yes, this condition is satisfied. So with this condition we understood, when it is satisfied, it is true, right, that whatever the data you have to insert, it is in the left substrate. It is in the left side of this particular node. Okay, this 100 node in the, so but thing is where in the left side where we have to insert. That is the thing, right? That is, we have to find it out. Now we have to go to current left and check. First, current is pointing here. Current left is what, 100 or current left is not null, you can see. Okay, so first you have check data is smaller than current data. Yeah, that is conditions true. Then you have to check if current left. What is current left? Current left is null. Current left is 200. It is not null. This condition is not satisfied, right? Then you have to come out of this and you have to check this part. Current is equal to current left. What is current left? Current left is 200. Means 200 has to pass to current. That means current will get 200. That means now you move this current pointer to here. Okay, this current pointer is moved to here. Getting it? Now after this line, you will, this particular curly brace, you will come out of this, you will come out of this particular block. Then again you will come here, and this is a while loop, right? Again you will check in the while loop. Again you will check in the while loop, and you will see this is an infinite loop. So again you will enter inside this function, this particular while loop, and again you will check data. What is data? 3. So is 3 smaller than equal to current data? What is current data? 5. So is 3 smaller than 5? Is condition true? Is 3 smaller than 5? Yes, condition is true, right? Because our current data is 5 now. So if it is true, then again it will check, is current left is null? Yes, this time it is, condition is true. Then current left is what? Null. Then at current left you have to put this new node. What is new node? 400. So 400. So 400 has passed to current left. What is current left? This part. So you will put 400. Then this, it will automatically point to 400 block. Okay, so you can see you successfully inserted at the left of 200 block this 400 block. Okay, at the left of 5 you had put third value. Okay, 3 value. So this is how the binary search tree works, right? Now again you are going to call insert 7. Okay, you are going to call insert 7. That means your data will be 7 here. Then when you call this insert 7, then it will go to the calling function, where it is a calling function here, and here at the data you will get 7. I had already mentioned here. Then again create node. Okay, so you will create one node somewhere. Okay, we create one node. Okay, with this particular data, what was the data? 7. With 7, and suppose its address is 500. Okay, and that 500 is given to new node. This 500 is given to new node. That means, and there would be one pointer called new node pointer, which will get 500. So when it gets 500 pointer, it will automatically point to this memory location. Fine. Again it will check if root is equal to the null. Yes, root is not null, right? Root is pointing to something. So if it is root is not pointing, then this particular code will not work. Then again what you will do, you will take one new pointer, that is current, right? You will take one new pointer, that is current, right? And what is root? 100. So 100 is passed to current. So current will point where the root is pointing. So current will point where the root is pointing. So it will get 100 and it will point to the root, because 100 to 100 is root is 100, right? It is point to the current. So at the beginning you have to make point current to the root, wherever the root is pointing. Then you will again get into the while loop. Then again you will check it's data. What is the data now? 7. Is 7 smaller than current data? What is current data? 10. Is 7 smaller than 10? Condition true. Then you know whatever the data you want to insert, that is 7, it has to be inserted in the left side, right? So Yeah, but left side where we don't know. So we have to till searches. Then we have to, then we will check its current left is null. After that current left, no, current left is also not null. Then you have to go to this line, right? Then you have to move this current pointer to current left, right? So current left is what? 200. So current will get 200. Then current will move to here, that is at 200 location, right? Then again it will come out of this particular block, then again it will come here, and again it will go to the while loop. Where is while loop? Here at while loop, and again it will start executing. While loop is infinite, right? Then again it will check its data is smaller than equal to current data. What is data? Our data was 7 and current data has updated, right? So 7 smaller than current data is 5. No, condition is not satisfied. Then it will go to the else part. Then it will check. Then we understood that it has to be inserted in the right side of this particular node at wherever the current is pointing. So now it will check its current right equal to null. Yes, current right. Current is here, right? It's null. Right is null. Then new node. What is new node? 500. Okay, 500 location. This 500 has to pass to current right. What is current right? Current right is this part. Then I will put 500 here. Then it will automatically point to 500 location. So you can see you had inserted, successfully inserted 500 block at the right of fifth data, right? 5 data. So this is how you have to insert a binary search tree. So this is how our binary search tree works. Okay, so after rest you can do it by yourself. So insert 12, insert 18. So if you keep on, so my intention was so that you can understand the flow of binary search tree code. Okay, rest you can do by yourself. So when you follow this insertion sequence like 10, 5, 15, 3, 7, 12, 18, this is the insertion sequence. So when you follow it at the end, this is the structure of the tree we got. Okay, so this is our BST binary search tree. So this is the structure we got, and after that you have to perform pre-order traversal and print it, means print the entire tree. So how you're going to do it? So pre-order, what is the meaning of pre-order? Pre-order means root, left and right, right? That is the meaning of pre-order. So whenever you see the root, you just print it. After that you keep on traversing in the left hand side, and whenever you're traversing the left hand side, wherever you see the root, print it. Okay, you keep on doing it, and after that you traverse to the right hand side. Okay, you might not understand like this, so I will show you with one simple like example. I will show you how the traversing happens. Okay, so at the beginning what you have to do is you just put some dummy nodes. Okay, this is a dummy nodes. Okay, then you perform a traversing. You start from here, root. Okay, so whenever you visit for the first time any node, pre-order, in pre-order, whenever you visit, because root, right? So whenever you visit any node for the first time, you just print it, that is 10. Then after that you just keep on traversing. First time you're visiting 5, right? Print it. Okay, then you keep on moving here. First time you're visiting 3, you just print it. Okay, then when you come here in the middle, this is second time, right? When you come here, this is third time. You don't have to do anything, just move ahead. Then you have to go to the calling function. This is second time you are visiting 5. First time you are visited already here. Then again, this is first time you are visiting 7. So print it. Then this is second time you are visiting 7. So don't do anything. Again here, don't do anything. Third time. This is third time you are visiting 5. This is second time you are visiting 10. This is first time you are visiting 15. So print it. Okay. Again, first time you are visiting 12. Print it. Okay. This is second time you are visiting so don't do anything. Third time you're visiting 12, don't do anything. And after that, second time you're visiting 15, don't do anything. This is first time you're visiting 18, so print it. Second time, don't do anything. Third time, okay, don't do anything. 15, don't do anything. 10, don't do anything. And after that, you just return. So this is a sequence uh, of pre-order. So when you use a pre-order traversal, this is a sequence of the element you're going to get when you're going to print it. Okay, so you can see 10, 5, 3, 7, 8. So this, in this sequence, the element will be printed when you perform a pre-order traversal. Fine.